Welcome to CODESYS webinar. My name is Anja Giesbauer, and within the next 30 minutes, I will tell you something about one of our newest products, CODESYS BACnet. Let's start with a short overview. At first, I will tell you something about the BACnet standard itself. As a second point, I will talk about BACnet integration in CODESYS. Then I will go on with some words regarding BACnet certification, and at the end I will sum all up. So let's start with the introduction to BACnet standard. What does BACnet stand for? BACnet is an abbreviation for Building Automation and Control Networks, and it is an open manufacturer independent communication standard for building automation. BACnet is developed by the American Society of Heating, Refrigerating and Air Conditioning Engineers, short ASHRAE. In 1987, BACnet development was started. In 1995, there was the first ASHRAE standard published, and in 2003, it also became an ISO standard. In Europe, BACnet is mainly used in the management or automation level of building automation as BACnet IP. In the US, it's additionally used also in the field level, so on the base of sensors and actors as BACnet MSTP. So what are the levels in building automation in general? You usually have the field sector where the sensors and actors like temperature sensors or light switches, everything else are. You have the automation level where the PLC stands, and usually above a management level for building control. BACnet is usually used in the levels between management and automation area. It also can be used in the area of measuring services, so between automation and field, but there are also a couple of other field-based system and proprietary protocols, like, for example, CAN. So what was the motivation for BACnet? So as you all know, there are a lot of different physical types like digital outputs, digital inputs, analog inputs, for light, switches, or temperature, and also virtual types, data types like calendar functions or controlling programs. And the problem was there are really many communication protocols for the different data types. And BACnet was meant to build up a solution as a standardized communication protocol. So a short overview to the BACnet standard. The standard itself is a very comprehensive and detailed standard with way more than 1,000 pages. It defines 7 network media for communication regarding to the OC layers 1 and 2. And it defines BACnet objects to represent different data types and functions, and also services for assessing and configuring BACnet objects. In this table here below, you see the different BACnet layers which are defined by the standard. So you have the BACnet application layer related to the OC model application layer, the BACnet network layer also related to the OC network layer, and in the data link and physical layer, you have the 7 defined network media. And what is mainly used is the BACnet IP standard, and this is also the standard which is integrated in the product CODESYS BACnet. So the BACnet standard defines so-called BACnet objects. Typical BACnet objects are, for instance, an analog input, an analog output, a calendar object or scheduler. And every BACnet object is child of a so-called BACnet device. BACnet objects themselves consist of so-called BACnet properties, which are very well defined in the standard. Such BACnet properties can be in general readable and or writable, and those BACnet objects must behave according to their BACnet properties, and this BACnet behavior is also very well defined in the standard. Additionally, the standard defines so-called BACnet services. So examples for BACnet service are, for instance, a read of a property, write property, or acknowledgement of an alarm. BACnet services are based on a classical client-server model. So BACnet Server in form of a BACnet device offers services used by different BACnet clients. And a BACnet device can be a BACnet server or client at the same time. There are different areas or fields of BACnet services. So for instance, field object access, file transfer, alarming, or remote device management. And like BACnet objects, also the services are very well defined in the BACnet standard. So let's look to the BACnet integration in CODESYS. What are the basic product components we offer with CODESYS BACnet? We offer an integrated device configurator, a protocol stack in form of a CODESYS library, a runtime system component, and of course device descriptions for BACnet servers, BACnet objects, and BACnet clients. For the product CODESYS BACnet, we integrated an external BACnet stack from the company MBS. And there are usually two ways, we implemented two ways of assessing this external stack. The one way is via CODESYS devices. The other way is via a component library in the runtime system. The external BACnet stack we provide is available for Windows and Linux systems. We integrated on the one hand CODESYS BACnet objects. First to say is that one BACnet server device representing one BACnet device is allowed per one PLC, and a BACnet server device has always BACnet object as child devices. The initial BACnet property set of each BACnet object is configured via the generic CODESYS device editor, and each BACnet object is represented by a function block giving access to all of its BACnet properties during runtime. On the other end, we implemented CODESYS BACnet services. So each BACnet server device has possible BACnet client services as child devices, and there are BACnet client services for the different BACnet service classes implemented already. Each BACnet client service is also represented by a function block allowing the access during runtime, and there are also simple wrapper function blocks which can be used asynchronously for the usage of BACnet client services. So let's have a look to the CODESYS integration and go on with the live demo. Let's switch to CODESYS. At first I will show you how easy it is to integrate a BACnet server into CODESYS. I started a standard CODESYS program with a CODESYS Control Wind device, which is the soft PLC we provide for Windows system on PC-based systems. And if you want to integrate a BACnet server here, you just have to click on Add Device, and you see here under a special category BACnet, you can integrate a BACnet server. Just double click on it. Now we go to the level of the BACnet server, and what you see here are different child objects you can integrate or add to a BACnet server. So there are BACnet clients, which represent the BACnet services I mentioned before. There is the BACnet folder object, which is just for ordering your BACnet objects within the device tree, and the BACnet objects, which I talked about before. So let's add just some objects, some generic objects, for instance, an analog value, an analog output, for example, calendar object, and scheduler. Okay, that's at first all you have to do. To build up or start the BACnet server, you now have to connect to your device with the integrated BACnet component. So we check the network for the PLC, which is not on my local device because I want to show you how I can connect to the server from a local external client on my PC here. So I connect to an external device and just start the server. Okay, now I start the application, and you see here in green with those circuits that the BACnet server is running, and the green color also indicates that it is fully licensed. So now we want to connect to this BACnet server with an external client, and now I explore the network, and you can see here there is the BACnet server. To convince you that we really talk about the same device, I show you that the BACnet server has the same objects here below. So there is the analog output object, the analog value, the calendar, the device itself, so the BACnet server, and the scheduler. Okay, now I want to show you that the server and the client are really communicating with each other. So therefore, I at first put an analog value to the watch window of CODESYS. So I take this analog value and the present value of the object, and you see right here the value of the BACnet analog value is 0 at the moment. That's what we should also see here. So we look at the analog value object and the external client, look for the present value, and it's also 0. Now with double click here on the present value, we can write the property. And for instance, we write the value 7 with a priority of a manual operator, priority of 8. Now I write, and what you see here is, okay, the present value is changed, and it's also changed on the server side in CODESYS. You could also write with a higher priority now, for instance, a value of 9. For example, with a manual life safety priority, write it again. Okay, we see again the present value is written, and it's also written on the server side in CODESYS. And when now this priority says, I don't want to write anymore, I just reset my value to a so-called null value. You see the priority of the value which was written before is still there. So this is also an implemented functionality of the stack. Now we can also reset the value again with a high priority reset value, for instance. Okay. What I also want to show you is alarming within the BACnet stack. Therefore, we have to change our project in CODESYS a little bit. So I log out again from the project and add a new BACnet object to the server, which is called a BACnet notification class element. Okay. So when we look on the configuration of the BACnet notification class, you see different values. What is important for us now is the notification class itself with the value 1. And we now want to use alarming on another BACnet object. We just have to set this notification class we defined here. So we go to the analog value, for instance, and set here a notification class value of 1. When we now see how alarming works, of course we have to look on the limits which are defined in any BACnet object. So for instance, in the analog value, we have here a high limit with a value of 1 and a low limit with a value of -1. So let's start the server again. Okay. Let's go back to the external client. And now first, we of course want to see the new notification class object. So I rescan the network, and you see, okay, the BACnet server now has the additional object notification class. So we go back to the analog value object. Now we are, and go back to the present value, which is 0 at the moment. So we write again a value, and now we want to write a value which is higher as the defined higher limit. So for instance, we write a value of 2. Okay, and what we should have is now an alarm, and this is what you see here. So you see the alarm that we have hidden the high limit, which was defined for the analog value. And of course, we can now reset the alarm with resetting the present value, for instance, to a value of 0. Okay. A last thing I want to show you is really, that permanent value changes can be detected by a client. So, for instance, we now write a really smart or really short program in CODESYS saying, okay, we take the analog output, for instance, and the present value, and add a value of 1 with each cycle. Okay. Login with download. And start the server again. So here we see now the online changes. We could also watch this within the watch window here below. Okay, so we see the permanent value change. We go now to the external client and to the present value, which is here. You can also see that the value is really changed permanently on the client side. Okay, so let's go back to the presentation. Let's talk about assessing the external stack. In general, with the CODESYS BACnet integration, there are 2 ways of assessing the external MBS stack. The standard way of assessing the stack is using the BACnet objects, which are represented as CODESYS devices. There are different advantages using this way, so you have really a comfortable access via BACnet object FBs, function blocks. There is no need for surveying BACnet IDs, and there is no need for building large initialization expressions for BACnet object initialization. There's also another way to assess the external stack in the runtime system, and this is via the component library CMP BACnet Doctor library. So the advantage of using this assess is that you really have a detailed access to all stack functionalities. The disadvantage is that you have to care for BACnet ID management, and you have to care for the really work-intensive stack initialization, and of course you have a higher risk of generating non-executable configurations. So the usage of the direct access via the component library is possible, but is really not necessary and should be avoided. Regarding BACnet object behavior, what is readily implemented in our product or within the stack? So therefore, it's important to say not every behavior specified in the BACnet standard is implemented by the stack. What is implemented is the complete basic BACnet object behavior, and only special object behavior has to be implemented by the user. So what does that mean? We prepared some examples for this different object behavior. So you see here in the table below what is provided by the stack. For example, simple BACnet property behavior like write or read a property, alarming, which I showed you before, COV messages, so like sending value change messages, or simple network identification messaging like IM and who is there for client and server communication. Examples for behavior which has to be implemented by the user, for example, data storage or integrating controlling mechanisms, backup and restore of objects, clock synchronization, or device restart. So let's have a look on BACnet certification. At first, what means BACnet certified? The BACnet Interest Group Europe and BACnet International provide tests for BACnet devices to ensure their compliance with the BACnet standard. For example, the ASHRAE standard 135-2010. Compliant BACnet devices are allowed to carry the BTL logo, which you can see on the right side of the slide. So since 2010, the BACnet test framework tool developed by MBS is also used for testing of BTL compliance, and this is also a possibility to pre-test your device with an application in front of a certification. The BTF tool allows also automated testing of BACnet devices. What else should you know about certification and which are the consequences? For certification, always a complete application is tested on a device. The test coverage for the certification test is specified in a so-called PICS, a Protocol Implementation Conformance Statement. And this PICS contains usually supported BACnet objects and the extent of their BACnet properties, as well as supported BACnet services and BACnet behavior, also called as BIBs, so BACnet interoperability building blocks. Simply, if a BACnet device passes those tests specified by PICS, it is certified and allowed to carry the BTL logo. A very important information is that no a priori certification for CODESYS applications or CODESYS devices is possible, so only a device with a complete application is certifiable. And depending on the specified PICS, it may be necessary to implement some additional BACnet behavior in the application prior to certification. So let's sum up. What are the benefits of using the CODESYS BACnet integration? Of course, BACnet in general is a manufacturer-independent communication protocol, especially designed for building automation, and really fits well to the manufacturer-independent automation software CODESYS. With CODESYS BACnet, you get a completely integrated BACnet configurator, so it's possible to easily link BACnet objects as devices in the CODESYS development system without additional tools. Via device properties, you have really direct access to BACnet properties, and there are a large number of pre-implemented and certifiable BACnet objects already implemented within the product. Within the BACnet integration, a really easy integration of BACnet devices and application in existing networks is possible without additional implementation effort. So if you want to know something about CODESYS BACnet concerning sales or pricing, please contact our sales team via sales@codesys.com. Important note for you is that there is also a demo version available with a limited runtime. What are the system requirements for using the product? At the moment, we support the operating systems Windows and Linux. The CPUs which are tested at the moment are x86 and ARM. And on request, we could also test more CPUs. On CODESYS side, you need a CODESYS development system with a minimal version of version 3.5 SP5 and also a CODESYS control version 3.5 SP5. On your device, of course, you need a communication interface, Ethernet or TCP/IP. And another additional information is that CODESYS BACnet orients towards AMF, ASA, and ASB standard. So when you have questions related to the webinar, please contact webinar@codesys.com. We also stay online now in chat for the next 10 or 15 minutes. And so I will thank you for your attention and say goodbye for now.